Welcome to Bug Banter with the Xerces Society, where we explore the world of invertebrates and discover how to help these extraordinary animals. If you want to support our work, go to xerces.org/give.
Hi, I'm Matthew in Portland, Oregon.
And I'm Rachel in Missoula, Montana.
Light pollution. Go outside at night and you'll notice the lights on buildings and gardens along streets glowing on the horizon. It might not seem like much, but this is changing the world for animals that rely upon darkness. Imagine evolving for millions of years with only the stars and moon and now being faced with a landscape full of additional light. What happens to insects when the night is full of light? Can fireflies coexist in urban areas? Are there things we can do to reduce our impacts? Joining us today to talk about these questions and others is Dr. Avalon Owens from the Roland Institute at Harvard. Avalon received her PhD in biology from Tufts University in spring of 2022, where she studied the impact of artificial light on bioluminescent fireflies. She also holds a BA in integrated biology from Harvard University and an MS in entomology from the National Taiwan University. Welcome, Avalon. We're thrilled to have you here, and especially because you are our first non-Xerces guest, which is awesome.
Yes. Thank you so much. I'm thrilled to be here. So honored to be the first.
We're really excited to pick your brain and to learn more about light pollution, especially from someone who has studied it.
Yeah, of course. Hit me.
So before we get into light pollution and your research, can you tell us about nighttime insects? I think fireflies and moths are the most obvious and probably the most commonly thought of, but are there other insects that are active at night?
Yes, I think, well, this is a huge, so much of the discussion around light pollution and insects and insect conservation, like humans bring a lot of our own biases to the table. This is something I'm sure you guys are familiar with. Like insects, a lot of us are they're very small, and so we don't really know what's going on with them. Similarly, like humans, we hang out outside during the day, mostly. Not a lot of people go outside at night. And so we have this bias where we think everything important is happening during the day. And this is just couldn't be farther from the truth. Most insects, so over 50% of insects, are active at night. And we have these classic examples, fireflies and moths, like those we are more likely to encounter. But all sorts of insects, like for every, you might be familiar with the honeybee. Well, there's other bees that are active at night. They're different species, but they are doing similar things at night. Bumblebees as well. There's ants, dung beetles, like all of the insects we're used to thinking about. Many of them I will either be partly or entirely active at night. And as we continue to learn about the natural world, we'll find even more species active at night because we just don't do as much research on nocturnal insect biodiversity. And on top of that, with climate change and human change of the environment, the addition of lights, etc., and increases in temperature as a result of climate change, a lot of things are becoming more nocturnal over time because it's cooler at night and there's fewer people around. And so the nocturnal niche is sort of getting invaded by a lot of things at once, including some insects. So there's a lot out there. It's not all fireflies and moths. There's a lot out there. And for them, light pollution is a totally transformative thing that we're doing to their world.
Mm-hmm. Over 50%. I didn't know that.
Yeah. I know.
Wow.
Right. Well, over 50% of the 24-hour cycle is dark, right? It kind of makes sense, right? And there's a lot of reasons to go out at night. So originally, I think most animals started doing it as a way of avoiding predation. So it's maybe easier to get around during the day. You can see more, it's a bit warmer, but there's a lot of things that want to eat you. And so the night becomes this like safe, dark place where if you can thrive, you can do really well, and sort of has expanded from there.
Wow.
You mentioned dung beetles, and I forgot that they were nocturnal, but it made me remember some research I read one time where the researchers figured out that the dung beetles were navigating via the Milky Way.
Yes.
And they put little visors on the top of the beetle's head so they couldn't see the sky.
Yes.
Found that they went in the wrong direction. So
like, I think dung beetles are a really great example because when you learn about them in textbooks, it's like the savannah and it's like really sunny out and they're rolling their ball of dung, right? But within a single genus of dung beetles, you actually have multiple species that are sort of stratified to different parts of the day. So you'll have your ones that are active during the day, and then some that come out right at sunset, and then some that come out right at night. And they are sort of adapted in different ways to these lifestyles, and it's how many species can coexist in the same area by using different parts of time in a way. And the ones that are nocturnal, they use the stars or the Milky Way or visual signals in the sky overhead as landmarks to guide them when they're sort of scooting their balls of dung. In their case, they just want to go straight so they can get away from the rest of their competitors as quickly as possible. But they'll literally, I mean, you can look up videos of this. It's incredible, right?
Yeah.
They'll make their ball of dung and then they sort of climb up onto it and they twirl around and they're looking up at the sky, sort of taking stock. And then they like decide, climb back down, and off they go. It's incredible behavior that relies on having pristine night skies as it happens.
Yeah, totally. So, I mean, what is insect vision like? I mean, how do insects, fireflies, say, kind of see the world?
Insect vision is pretty hugely diverse, and it's also kind of modular in this cool way, in that a particular insect species is likely to have vision that's very adapted to the things it needs to do, more than, I would say, vertebrates. We have sort of general purpose vision. There's lots of tasks that we are capable of completing. So fireflies, as an example, they're really nocturnal. So number one, they have to be very, very sensitive to light. So they have these big eyes that can take in a lot of light. And that comes with a few trade-offs. So they also see things a bit more slowly, if that makes sense. So in terms of like frames per second, they have generally, it takes them a longer amount of time, a longer fraction of a second to collect enough light so that they can form a picture. So they see things kind of slowly, and they also see things as kind of blurry too. Like we often, human bias once again, we imagine insects are seeing the way we see, and we can resolve so many details of our environment. But a lot of insects, especially nocturnal ones that are just trying to get as much light as possible, it'll be sort of blurry around the edges. They're not really able to make out details the way we can. And then the big one is they also have more limited color vision, fireflies in particular. Fireflies are essentially interested in seeing one thing, and that is other fireflies. And so they're really good at seeing the green color of others of their species. They can also see UV, which we could talk about why that is, but it's probably useful in some way. But that's it. And they just basically their main thing is they have a green photoreceptor and they use that to see other fireflies. And that's all they need. However, other nocturnal animals, including moths, some of them have a greater capacity for color vision at night. They're actually better than us at seeing color at night. So they have, we have red, green, and blue cones. These moths have UV, green, and blue. That was the wrong order, but UV, blue, and green. And they can use those to tell the color of a flower under moonlight, when for us, if we were fully dark adapted, everything would be black and white. So an incredible capacity for vision at night, which comes with some trade-offs, all of which are designed around, accomplishing your goals under really limiting light conditions.
So it's important to have that darkness, because without darkness, right, they wouldn't be able to use these adaptations. It would kind of throw everything off.
It throws everything off. So when you light up a space, all of the sudden, all of the, I mean, some of this is speculative, but let me speculate.
Let's.
All of these day active insects that are super good at seeing under bright light, all of a sudden they have a huge advantage. There's a really cool study about, I'm going to say it's a bumblebee. I hope this is true, in the tropics, where they have switched to a more nocturnal lifestyle to avoid predation or competition for resources. I think probably competition. And the researchers were asking, how do they accomplish this? They have the basic bumblebee eye, which is not historically very good at seeing in the dark. They're a bit smaller than like moth eyes or firefly eyes. So how do they manage it? And they did a bunch of studies on like how fast they see, how many frames per second, how blurry is it, this and that, and ultimately concluded one of the ways they manage is they're just not very good. So they'll hit things a lot, they'll bump off surfaces. It takes them a couple times to find their nest because they're like sort of their reaction time is not quite right. But it's enough to get by. However, if you light up the space, all of a sudden it's enough for a lot of animals to get by. And then there's a lot more competition. And then, the poor firefly that spent millions of years getting super sensitive eyes is just totally blinded. And meanwhile, everything else is more able to cope, including humans. That's why we light it up, right? We want it to make it the night more pleasant for a day active animal.
Yeah, and you talked about one of the purpose of fireflies lighting up, like their one job is to see other fireflies so that they can mate and communicate. And if that's taken away because of this artificial light that is now there in the darkness, like how does a species survive that? I mean, we're going to get more into this, but it's just so important. I think we've laid the framework that these animals are adapted to be living at night for very good reasons, and they need the darkness. That's like the key is that they need the
100%.
darkness.
And I think you mentioned it a little in the introduction, but I cannot overstate, for all of evolutionary history, the night has been totally dark. And so what we're doing to it is unprecedented. These animals are not prepared to cope with change of this kind. And many of the other things we point to as drivers of insect decline, they sort of do have evolutionary analogs. So climate change is happening much more rapidly than it ever has before, but like temperature fluctuations are within the realm of an insect's life already. They kind of have the ability to adapt to a certain extent. And even pesticides, a lot of them are based off of plant defenses or other chemicals that, other sort of control mechanisms that insects have evolved to cope with to varying degrees. And so you see things like pesticide resistance, sort of utilizing the sort of genetic tools that these insects have to face threats. But there has never been a streetlight, like for all of evolutionary history, there's never been a streetlight. And so like fireflies, the poor fireflies, right? They had no way of knowing this would happen. And moths and other insects too will react in these really weird ways because like, how could they have known?
Yeah, and I know in the introduction we refer to it just as light pollution, but scientists like yourself who study it, you have a more specific name for this kind of nighttime lighting. Can you tell us what that is and how you define it?
Yeah, so our jargon of choice is artificial light at night, or ALAN. And there's some key reasons that we talk about it this way. So light pollution, this term is quite old, actually, I mean, relatively speaking, and has been used a lot by astronomers, but also city planners generally. Light pollution is any light that is wasted. And so it's a very human definition. We're assuming the light has a purpose, but if you get glare, like when you're driving and the car headlights like make it hard to see, this is wasted light. It's not helping people, it's hurting people, and therefore it's pollution. And similarly, if your street light lights up the sidewalk, but also part of the lawn where nobody should be walking anyway, this is wasted light. This is light pollution because you're wasting money and you're not accomplishing your goals. So from an ecological perspective, all light is pollution to insects. They don't need it. They don't want it. And so I like to speak about it more generally as artificial light. But the other thing is it has to be at night because that's when it does the most damage. And also, to take the scientific view, we have to be a little more objective. Like pollution is a loaded term, so we want to just, I have no opinions about whether it is good or bad. I simply want to know how the insect, responds to it. So that's another reason we talk that way.
Yeah. No, it is really good to have defined it like that. I mean, I know that term and I use ALAN, but I hadn't thought of it as pollution being waste. And therefore this shift of the definition. And I guess I should also tell people that if we complain about ALAN, it's not personal, right? We are talking just
Sorry to
about the
all the
artificial.
Allens out there. Yeah.
Yeah.
So I am excited to ask you this question. Can you tell us about your research? How did you go about understanding insects' reaction to different light?
Yeah. So I'll talk about my work on fireflies, which is more or less, I have like a complete package there. There's other stuff we can talk about later with moths that I'm kind of still working on. But yeah, so for my PhD research, I sort of wanted to get the full picture of what artificial light is doing to the local fireflies around New England. And that can mean so many things, which is why it's such a great thesis topic, right? An insect life cycle is very complex, and there's many different ways that artificial light can interfere with this. And so my idea was to take a whole life cycle approach. So to look at, and this comes from a conservation perspective, right? So the whole life cycle matters. A firefly has to get all the way from egg to adult to more eggs in order to make more fireflies, and this is what we want, right? And so I did a few things in the lab, rearing fireflies under different light conditions and seeing how they did, looking at how they move also, because you can put a light in a backyard and all the fireflies might disappear, but does that mean they have died? Does it mean they're somewhere else? Like, movement is a big part of this. And there's some interesting stuff there as well. But the bread and butter, and I think the most fun thing to talk about on a podcast is my work on firefly courtship and reproduction. So the final stage, once the firefly has gotten all the way past 1 to 2 years of larval development, which, you know, is no joke. That's like most of their time is spent as a larva. But assuming they've gotten past that, they've pupated, they've come out, there are adult fireflies flying around. These are the ones we know, the ones we love. They're only alive for like 2 to 3 weeks. During that time, how does light affect their ability to find dates, to go on dates, to have a good date, and to lay eggs, and to make more fireflies? And so I've looked at this in quite a few ways, usually focusing on not only the effect of light itself, but various kinds of light. And for a long time, I was thinking a lot about color. So different colors of LED light at different brightnesses, how does that affect firefly courtship, which is when the male and the female firefly are flashing back and forth. I guess you guys did a podcast about fireflies, so you're all experts, and I don't need to explain. But yeah, when the fireflies flashing back and forth is an essential precursor to mating. If they don't have a nice date, they're not going to mate at the end of the night. Looking at how in the lab and in the field, you know, we would find pairs of fireflies that were chatting happily, put a light on overhead and see what they did. And there was I had a very interesting realization quite early on, which is has to do a little bit with, again, human bias and how we see things. So there had been people before who had gone out into a field and put a light up, and they had shown that the firefly display as a thing, all the flashing activity, it would decrease a little bit. Maybe I'm going to say around 50%. So they would flash about half as much. Okay, so that seems bad, right? But it could actually be worse, and it is in fact worse because the firefly display is made up of male fireflies flying around doing their courtship advertisements. So they're telling all the ladies who are on the ground how great they are and how much better they are than the guy that's flying, a couple feet to the left. And then on the ground in the grass, the female fireflies watch this display just like we do. And whenever they see a male that they like, they'll flash back and the two enter this dialogue. And so when we look at the effect of light on the firefly display as a whole, we're only looking at the male behavior. How do the males respond? And in terms of firefly conservation, aka firefly reproduction, what the males are doing doesn't really make a huge difference because there's like a lot of them. They're sort of disposable, usually. Like the female will only mate once per night. She's got a lot of guys to choose from. And it's what she decides to do that ultimately determines whether or not we're going to have fireflies next year. And it turned out in the lab and in the field that although the males would flash less when there was a light overhead, the females would go almost totally dark. So they were much, much more sensitive than the males, which, not to anthropomorphize too much, but it kind of makes sense if you think of it in terms of, the female is sort of picking whichever guy she likes, and she's alive for a while. She wants to make a good choice for her eggs. And so she can afford, if there's a light overhead, it's just like the vibe isn't right, she'll just sort of decide, I'd rather not. Meanwhile, the males, they're pretty desperate, right? All they have to do is find a mate. They'll mate with pretty much anybody who flashes back at them, including me using a pin light. They'll land and try to mate. Or the predatory fireflies in New England, which we could get into. They attract male fireflies and eat them. So males will attempt to mate with anything, including an LED and their top predator.
Oh gosh, that's tough. What a tough life.
Yeah. So
How embarrassing.
it's a little awkward. So like the fact that they stop flashing even a little is significant, but like they're gonna keep trying no matter what. And so they are really giving us a false impression of how bad it is. Because if the males keep flashing, but the females go dark, okay, you might look at that spot and say, probably the fireflies will be okay, but next year you're not going to see any because the females just sort of dipped out.
Wow, it's so interesting. So obviously, Alan interferes with insect behavior, whether it's mating or navigation. I obviously, anybody walking outside at night or, observing the different lights that are out there, there's different colors that are just different brightness. Do these different colors or brightness impact insects in a different way? Are there some that are better than others?
Yes. Oh, yes. Thank you. This is the other part of the whole reason I did all that research. That's good. Yeah, I think to a certain extent, but I've sort of moved away from thinking this way because human bias, it just feels like a very human desire to like, if we could only find the right tool for this situation, we can fix it. And it is true that a lot of insects are not very good at seeing red, and humans are pretty good at seeing red. And that is sort of true in terms of probability. So anything kind of close to red is going to be better than anything pretty far from red. So like amber or orange light is better than green light, which is better than blue light, which is better than UV light, which is the most attractive. So it's generally true that we say longer wavelengths, like the warmer colored lights, are less visible to more things. However, there's never going to be like a color of light that only humans can see and nothing else can see, because we live in an ecosystem and humans, like, we're special, but we are just like animals, like anybody else. So for insects specifically, I think red light is pretty good. Unfortunately, people don't like red light very much. They tend to prefer something more like amber or yellow. And for fireflies specifically, yellow light is quite bad because it looks just like a firefly. Fireflies are green or yellow, so there's that overlap. Fireflies, they have their big green photoreceptor, which they're only using to see other fireflies. And so anything that's similar enough to green is going to have the biggest impact on their courtship and reproduction. And that's unfortunate because fireflies are also really good ambassadors for like environmentally friendly lighting. And so, if you like dark skies, all the dark sky people say use amber lights, and as you put amber lights within the fireflies, it's like kind of a mess. And that's one reason I've moved away from thinking this way. And brightness too, like, it's not obvious to me that a dimmer light is actually better because insects' eyes adjust just like ours do. And so it's actually an open area of research, I would say. But one thing that's certainly clear is that there are much easier solutions to this problem that are uniformly good. And the number one, I would say, is motion detectors. If people are there, have as many lights as you want. If people aren't there, we should not have lights. That's light pollution, by definition. And how could anybody argue against such a common sense solution? I mean, people can, but they shouldn't. And then number two is curtains. I really feel like lights from houses going out into the environment especially in some of the semi-natural areas where I do field work. They have a very big impact. And then timers are a good solution as well. So for like, less good for fireflies because when they're active is usually when people are out, but for things active at like 3 a.m., no human, I mean, some humans, but very few humans are out at 3 a.m. We could probably turn out a lot of lights at that time.
Yeah, but we're talking about lighting here, and I know now there's been this kind of move towards low energy LED lighting and so on, and those often are brighter. I mean, in our neighborhood, they've come through in recent years and gradually swapped out the old yellower
Yeah.
lights for LEDs, and they're brighter. And some people like them, and some people are like, this is just too bright.
Yeah.
It, it just seems like that's a technology change and maybe an environmental benefit, and yet we don't want to kind of demonize that, you know.
So yeah, I am actually an LED advocate. I think LEDs are great, even though they're doing so much damage, but it's not their fault. They're like too powerful. And especially when they were first produced, they were just super, super bright. They can be made as dim as you would like, but we just don't think this way as people. We think the big number good. There's 2 flashlights for sale. One says 10,000, one says 20,000. I'll buy the 20,000 because it's a big number, right? We don't often think about like ceilings on how bright something should be. I think this also explains why car headlights are so bright these days. People buying cars are like, you're choosing between, well, I want to see better. But this leads to this like rising tide effect where now the old lighting looks really dark in comparison to the new LEDs. And so you need to increase that and increase that. And so it's a human behavior issue, not a technology issue. And LEDs are super energy efficient. This means people leave them on all the time because it's very cheap to do so. But ultimately, it is good for the Earth to switch away from older lighting types because of the carbon emissions associated. I mean, lighting is one of the main uses of electricity municipally. I mean, it's just one of the big ways that we spend our money. So I think LEDs are here to stay. They can be made dimmer. They can be made different colors. And importantly, they can also be linked with smart devices to like motion detectors and sensors of different kinds to make them really work for us instead of against us. But it does take a little bit. You as an individual like can only do so much. It's a community effort and it often is best on the local level to like work with your neighbors and be like, we all want to just lower the amount of light, have a better night sky, have a better nocturnal ecosystem. And then you will be surprised how much you can see under quite dim light. It's all relative,
I was just thinking, I get really frustrated when my partner uses his phone when I'm sleeping. I'm so sensitive to light. And I was just thinking, if I was an insect outside and I couldn't find a dark space, I'd be so mad. I'd be so annoyed. Be like, just turn the lights off.
They don't have curtains. They don't even have eyelids, for goodness sake. Like what is an insect to do? We make it really hard for them. And we don't have to.
Yeah, I'm going to ask a really silly question now, but when you talk about light and insects, everybody thinks about moths circling around. Is there an easy answer to why moths end up doing that?
It's not a silly question at all. It's my favorite question. It is surprisingly difficult. You would think this is something that we've known that moths do for thousands of years. Like ancient Roman beekeepers would use flames near their hives to get the moths to control wax moths. So they would use fire as a pest control method. So we've known that they do this for so long. Why did they do this? Oh, such a good question. There's many theories, and I don't think any of them really paints a full picture. And I also think human bias, once again, we tend to view flight to light behavior as one thing because we see it, they're either at the light or they're not, and we categorize it in our mind this way. But there's many reasons that you might go towards a light. So I think to some extent, all of the theories are true. So one is that like the dung beetles. So the dung beetle using the Milky Way as a landmark, it's trying to say, okay, there's some sort of distant thing. And if I follow the line of the Milky Way, or if I keep the Milky Way pointed to my right or whatever, that will help me keep a straight line. And so similarly, many moths, especially migratory ones, may use the moon as a landmark
Mhm.
and either fly straight towards it or put it to their right, put it to their left. This works fine when the light source is at an infinite distance, like the Milky Way or the moon. But if it's a street light, if you sort of keep it on your right, you will actually end up spiraling into it, because you
Mhm.
will get there. It's like, yeah, you are not expecting it to be actually achievable. So then the moth gets there, and then what? It's like the dog that is chasing the car catches the car. Like, what do you do? And so at that point, when they're close to the light, there could be a lot of other things going on. So a lot of lights are hot, and that might interrupt
Mhm.
their flight behavior in some way. And there's also a new study. So active research is still happening. A new preprint came out only a few months ago, positing that part of the reason that moths will sort of swarm around lights and look as if they're unable to escape is because they actually don't know which way gravity is. They're so small that they can't feel it. And this is, makes sense. Insects generally are quite small. And so the way that they've figured out of knowing which way is up and which way is down is by keeping the light half of their eyeball overhead, because the sky is
Mhm.
light and the ground is dark.
Hmm.
Usually, and at night, this is also has been the case for like millions of years, right? The sky is bright with stars, the ground is dark with shadow, etc. But if you're next to a light, all of a sudden the bright side is over to your left or to your right, and then just like a plane that sort of loses control, if they're flying against gravity, they get all confused. So that's a possible reason. And then there's other theories about, is there something about the light itself that's super attractive, like the insects want to go to it itself?
Mhm.
And UV lights are most attractive to insects. So the question naturally is, why is that? What is it that they like? And I think this theory has, sort of fallen by the wayside in recent years, but I feel like it needs some love, because it's certainly true. From my experience, like if you have a housefly in your house, it'll usually fly at the windows, and it's because it wants to get out. So a lot of insects will fly to light spaces because they want to escape in some way. And I think that they don't, again, their vision is super blurry, right? They don't know that a street light is not like a window in a dark, like that, they don't know a lot. They're doing their best. So they might be trying to get to the light itself because they think it's something good, but it's not.
Yeah. So I just have kind of an odd question, but are there any insects that are benefiting from Alan at all?
I think yes, maybe speculative, but I'm going to speculate freely. It's like so many things, it's an environmental disturbance that sort of like shakes everything up.
Mhm.
And so one thing that you'll often see, moths, mosquitoes, gnats, other insects will fly to light, and then predatory insects will sort of come behind and be like, well, this looks like a good place to have a snack. So ground beetles will forage at light. A lot of spiders do this as well. And so they're sort of exploiting this behavior. What is the ultimate outcome? Not sure about that one. I mean, in a way, in theory, these like predator-prey relationships should be self-balancing in some way. Fireflies is an interesting one, and anything with like the dung beetles we talked about, with like its own little niche of time, because light pollution often creates sort of an eternal twilight. Those animals that have evolved to be active during twilight, all of a sudden their habitat is twice as big, right? It used to be 30 minutes around sunset, and now with all the lighting, it's like an hour. And so I do think that those species might be doing pretty well. They can get more done, and they are just like totally primed to take advantage of these varying light levels. And with fireflies, I have some reason to think that some of them are taking advantage of this. So the most common firefly in the US, Photinus pyralis, is also pretty dusk active around sunset, and really likes sort of suburban lawns. And you'll even see them flying around Central Park in New York City. So they're quite urban little fireflies, and they are moving upwards every year with climate change. They seem to be doing pretty well. And this frustratingly, just like the flash display situation, it's very misleading, because if you see a firefly in Central Park, you're like, that is great, fireflies are doing amazing. Most people don't even know that there's more than one species, and so they think everything's fine. But there's all of these rarer, more delicate nocturnal species that are probably being pushed out. And in fact, when I think, from my personal experience, the fireflies I see around Boston versus, outer, more in Western Mass, the fireflies around here are a lot more dusk active. They're kind of the same few guys that are active more at sunset. And so, to be determined, I guess. I can't say anything definitively, but it makes sense to me that we are seeing this loss of pure nocturnal diversity, much of which is already hugely underappreciated, and so much of which we probably won't even notice it once it's gone.
When you see abundance of one, that's not necessarily a good thing, because we're losing that overall diversity.
Exactly. So if there's one thing I could hope people would take away from like my work, my legacy, it would be that there is more than one kind of firefly, and they are all different and unique and special, and like we need to care about all of them, not just the one that's most common.
But so how can we care about them? I mean, are there things that we can do to offset, Alan?
Yeah, I think so much low-hanging fruit when it comes to light pollution. Unlike many of the things that we're doing to the earth, this is a problem that we can solve. We can solve. There are no residual effects of light pollution. So when you turn out a light, the problem goes away instantly. And it saves money to do so. So the only thing we have to do, just the small thing we have to do, is change people's opinions and make them see it as a problem. Most people just haven't really thought about it before. Human bias. You go to sleep at night, it's like not a big deal. Maybe you don't like light from phones, but otherwise you're not thinking about, even I think a lot of the insect decline literature, like we have so many entomologists are going out to these sites and they're seeing fewer things and like feeling this change in a really personal way. And I bet a lot of these people have never been to these places at night. Like they don't even know what they look like at night. And so light pollution doesn't often come up as a cause of declines because we're just not thinking about it. To get back to your question, yeah, I think turning out lights that aren't needed is the biggest one. And purely aesthetic lighting, especially in the summer months when most insects are active, I do not recommend. I don't think people ever need to feel unsafe. But I think, the luxury of aesthetic lighting, especially not, we're not like talking about like downtown Boston, kind of a lost cause in terms of light pollution, but like vacation homes, beautiful forest retreats in Maine and Pennsylvania. Like these are some of the worst offenders in my mind, because it's some of the only light around and it is purely luxury. I just like my house to look nice, or universities that light up buildings, facade lighting. That's just, you really can't justify that, in my opinion, especially if you care about biodiversity and conservation. So as long as if you're out there using the light, I think it's fine. Otherwise, turn it off or put it on a motion detector.
Yeah. So it sounds like it's a fairly simple solution.
Fairly simple, and yet, it also
Yeah.
requires a little bit of persuasion, I think.
Oh yeah.
But fireflies are great ambassadors for this. I've been really encouraged. Like people want fireflies by their house. They want to have this experience for them and their children. And I want that too. So I think it can be done. And I think turning out the lights really helps.
Well, this has been so informative. I have learned so much, and I've so enjoyed hearing about your research and about the things that we can do to help fireflies. We're going to end here on my favorite question of what inspired you to study the impacts of artificial light in insects?
Great question. I got into this through fireflies, and I don't have a beautiful story about catching fireflies as a kid. I'm from Idaho. There are fireflies there, but I had no idea. They're not super common. But I just fell in love with insects after I came to the East Coast. I saw my first fireflies while I was an undergrad, and I just thought it was amazing. And then during my master's, there was an opportunity. There was a a lot of funding in Taiwan for firefly conservation because of the great connection that people there have to fireflies, and firefly tourism is a very big industry. And that's sort of the moment that it got started. As my advisor just asked, do you want to work on fireflies or bees? And I was like, well, I love bees. It's actually the wrong audience for this joke, but I was like, obviously fireflies, they're so cool. And what that project, it was not actually conservation per se. It was sort of an interesting question about how insects live in the city. So we know that birds in the city sing louder because it's very noisy. And so the question was, do fireflies flash brighter because it's so bright outside? And it took me in a lot of weird directions. I won't get into it, but the answer is yes, to a certain extent. They will compete with our lights. As long as within a certain range, when you turn on an overhead light, they'll try a little bit harder to be seen. What that range is and how effective that adaptation is, I mean, it's not the full story, but there's something about it that's so inspiring that I just, had to continue to pursue these questions. And it's something I really believe in, and something that really motivates me. Like I do think, fireflies, they will be okay if we do the right stuff. Xerces has been really so great for this with the firefly conservation that you guys are doing. And light pollution too. Like, this is a problem we can solve. So it feels good to be able to make a difference in some small way.
I feel so hopeful after hearing that story.
Yeah.
I do hear a lot of anecdotes of folks saying, like, there were so many more fireflies when I was a kid. Where are they going? And I think people are starting to pay attention. And I'm glad there's people like you out there doing this research, because it's so important for us to understand their biology and their behavior for us to know what to do and how
Yeah.
we're impacting them. So thank you for your super important work. And thank you for being here today and answering these
course.
questions. It was really, really wonderful. It was such an honor to have you. And yeah, you were the perfect first non-Xerces guest.
The honor is all mine. I'm hugely delighted, and I will come back anytime.
I have more questions, so we will definitely have you back. Well, thank you so much.
Bug Banter is brought to you by the Xerces Society, a donor-supported nonprofit that is working to protect insects and other invertebrates, the life that sustains us. If you are already a donor, thank you so much. If you want to support our work, go to xerces.org/donate. For information about this podcast and show notes, go to xerces.org/bugbanter.